Let x be a random variable, and let's say it has m outcomes, u1, u2, up to um. For example, a normal die has 6 outcomes, that is 1, 2, up to 6. If we observe this random variable n times, we will get a dataset, x1, x2, x3, up to xn. So here means in the first observation we got x1, second observation we got x2, and so on. For example, if you throw a die 100 times, the first one could be a 3, the next one a 1, the next one a 1 also, then a 5, and so on. Then we can calculate the mean of this dataset, and let this denote the mean of this dataset. And you can get the mean just by adding all the data and dividing by the total number of data. An alternative formula for the mean is given by this one. And here f1, f2 and so on are frequencies. That is, f1 is the number of times outcome 1 happened. f2 is the number of times outcome 2 happened. And here n is just the sum of the frequencies. And the third way of writing the mean is given by this formula. And here R1, R2 and so on are relative frequencies. And relative frequencies are just the frequency divided by the total number of times you have repeated the experiment. And here all the relative frequencies sum to 1. So you can use any of these 3 formulas, so which one you choose depends on how you're given the data and which is most simple to calculate. Since we've already seen how to calculate the mean, you can check up here if you want to repeat how that is done. An expectation value is a concept having to do with a random variable. So let's say you have a random variable x, then the expectation value of that random variable is denoted by mu. And per definition this is given by this expression here. Here p1, p2, pm are the probabilities for the different outcomes to happen. So outcomes u1, u2, um. So those are the outcomes of this random variable. For example, for a normal die, we have the probabilities 1/6, like this, and the outcomes are 1, 2, up to 6. And if you calculate this one, you get 3.5. So this is the expectation value of a normal die. So what does the expectation value mean? If you throw a die a couple of times, you will get some outcomes, and you will have a mean for that dataset. If you observe x infinite many times, or in practice a large amount of times, the mean you will get will be close to the expectation value, or exactly the expectation value if you observe it infinite many times. The expectation value is equal to the mean in the limit when the number of observation goes to infinity. So that means if you throw a die millions and millions of times, your mean will be very close to 3.5. So let's say you throw the die n times, and then you calculate the mean. If you throw it 10 times, you could basically get any value. Let's say you get the mean of 4 point something. If you observe it 100 times, you can also basically get anything, but probably close to 3.5. So let's say you got this. And then if 10,000 times, then maybe this, and 10,000 times like this. And if we now connect these points, we get this. And here we have the line corresponding to 3.5. That is the expectation value. So we see that the mean will approach the expectation value when the number of times we throw the die increases. Let's take an example. So let's say that you are at a casino and you throw a die. Then depending on the outcome, you either gain some money from the bank or you have to pay the money to the bank. So if you get outcome 1 on the die, you have to pay the bank 130 in whatever currency. And then if you get 2 on the die, you have to pay 50. If you get the 3, you win 1. And if you get 4, 5 and 6, you win 10, 25 or 140. So is this a game you should participate in if you want to win money? Then you can look at the expectation value. So the expectation value in this case will tell you what will be the mean winning if you play it a lot of times, this game. So here the probabilities are just all the same again. So for the first outcome we get the probability 1/6 times the outcome minus 130. Then we do the same for all others. Then we get like this. And of course, it wouldn't be a normal die, we wouldn't have the same probabilities here. So there don't have to be the same probabilities here. But in this case, there are. And if we calculate this one, we will get minus 2/3, which is roughly 0.67. That means that every time you play, you will in average lose $0.67, for example. So since this is negative, this means that this is not a game you should play. If this would have been 0, then it wouldn't matter if you played it or not in the long term. And if it would have been positive, you will have won money in the long term. So in this case, the expectation value is the amount of money you will win or lose on average every time you play.